Welcome to Math Science History. I'm still on a break. I will be back next week, but today I am posting one of my absolute favorite podcasts. Before Isaac Newton's ideas reshaped Europe, his work struggled to gain traction in Italy. This episode revisits the remarkable life of Laura Bassi, the first woman in history to hold an academic chair, and the physicist who championed Newtonian physics against fierce intellectual and social resistance. In the year 415, the infamous philosopher and mathematician Hypatia of Alexandria, Egypt, was savagely murdered by church monks. This murder shocked the Roman community and its government leaders. Hypatia was known far and wide as a respected philosopher, mathematician, government advisor, and a professor. Hypatia, The Sum of Her Life, is a book that I wrote that looks not just at the circumstances surrounding her death, but also at the sum of her entire life. I weave in the details of her education, disciples, Neoplatonic philosophies, female contemporaries, and the many mathematics that she wrote and taught about. There is truly more to Hypatia's life than her death. Hypatia, The Sum of Her Life, written by me, Gabrielle Burchak, is now on sale on Amazon. Buy your copy today. Newton published his laws in 1687, and at the time, they were revolutionary. Today, Newton is known around the world, but there was a time in the late 17th century when he was only known in parts of the world, excluding Italy. That is, until the brilliant Italian physicist and academic Laura Maria Caterina Bassi became one of his greatest champions. Il fisico geniale accademico Bassi, the brilliant Italian physicist and academic, was born around October 31st, 1711. Even though Hypatia was one of the first female professors in the world, Bassi was the first woman ever in the history of the world to hold an academic chair and become the highest paid lecturer of her time at the University of Bologna. Bassi was raised in modest surroundings. Her father was a lawyer from Modena. She attended elementary school, and upon completing that, she began to take private lessons. She studied from Father Lorenzo Stegani, who taught her Latin, French, and arithmetic. She also studied from the family doctor, Gaetano Tacconi. For 7 years, she learned and mastered Latin and Greek, as well as the sciences, mathematics, and philosophy. However, her relationship with Tacconi began to decay as she found interest in Newtonian physics, which Tacconi adamantly dismissed. He wanted her to focus on something less controversial, like something from the Cartesian teachings. Regardless, her curiosity for Newtonian theories moved her forward. It inspired her and spurred her into the academic limelight. No doubt she was incredibly learned, a prodigy, and an intellectual's intellectual. Bassi became so famous for her acumen that in March 1732 she joined Bologna's Academy of Sciences. Then, on April 17, 1732, she publicly defended 49 theses at the Palazzo d'Accursio. This was her breakout moment. Bassi was 21 years old, just 21, and ready to take on academics. A month later, in May of 1732, the University of Bologna awarded Bassi her doctoral degree. But it didn't end there. Another month later, she defended 12 more theses, which earned her the unprecedented position of lecturer at the University of Bologna. Yet, much like the societal pressure that Hypatia endured, which led to her declaration of virginity, that's another story for another podcast, Bassi grappled with her reputation as a female scientist. She wanted to maintain her work in science. However, the university was limiting her opportunities to provide reports on her research, as well as give regular lectures. She was kind of forced into teaching from her home because of this. Additionally, the university was pushing her to write poetry and provide commentaries on literature. These two areas of academics were not in her wheelhouse. In a letter to Flaminio Scarselli, she writes, "I fear that I would gravely offend the Muses were I to present myself as their servant, who have the honor of seeing them merely in the distance, fleetingly." In other words, she's so far away from literature. Why is she writing commentaries on it? Instead, experimental physics, la nostra fisica, tugged at her heart. It encompassed her mind and filled her with steadfast passion for experimental science. Unlike Hypatia, who taught in Alexandria in 400 CE, and who chose virginity because it gave the impression of pure virginal dedication to her role as a professor, teacher, philosopher, and academic, Bassi chose marriage. Marriage would allow her to visit her colleagues and allow her colleagues to come visit her without any public scrutiny, judgments, or apprehensions. And so Bassi married Giuseppe Verratti, also a scientist, but not nearly as brilliant as her. Many commented that she married somebody who was not her intellectual equal, but he was scientifically curious, which was important to her, and which inspired them to work together in their own research facility in their home. And in keeping with societal expectations, Bassi and Verratti had 12 children. Sadly, only 5 of those children survived infancy into adulthood. Between raising children and maintaining her level of research, as well as her position at the University of Bologna, her opportunities were dwindling. That is until she met Prospero Lambertini, who would eventually go on to become Pope Benedict XIV.
We'll be right back after a quick word from my advertisers.
The Pope became her greatest champion. The Pope was a big supporter of the sciences. In 1745, he financially supported a research and experimental group called the Benedettina. Bassi hoped to become a member of this elite group of scientists. However, her intellectually inferior husband instead was elected to the Benedettina. After 12 years, she had enough. She approached the Pope and asked if she could be added as a 25th member. The Pope unyieldingly agreed to let her become a member, despite the pushback that he endured from existing members. This became her second chance. As a member of the Benedettina Research Group, she now had the platform that she needed to deliver annual reports on her scientific research, which included her work on hydrodynamics, Newton's light refraction, and Boyle's law of gases. Mathematically, she studied the flow of water in canals, which in some way would be the precursor of work with the Navier-Stokes equations. And then there was her work with electricity. This is where she gained her greatest respect. Bassi, in her lifetime, authored 28 papers. Most of these papers covered topics in physics and hydraulics. Voltaire highly respected her. In a letter to her, he wrote, "There is no Bassi in London, and I would be much happier to be added to your Academy of Bologna than that of the English, even though it has produced a Newton." In 1776, she obtained the position of Chair of Experimental Physics at the University of Bologna. Her husband was given the job of her lab assistant. She became the first woman in the history of the world to hold an academic chair. Additionally, over the years, she had been advocating for herself for more pay. And so, as a result, by the time she took the role of chair, she obtained the highest salary for lecturer at the university. Sadly, just 2 years later, she passed away. She left a tremendous legacy that included a life story that served as inspiration for future women in STEM. Today, as we speak, or as I speak on this podcast, there are about 800 million devices using Microsoft Windows. I know that sounds like a non sequitur, but go with me on this. Everywhere we look, we see the Microsoft logo. It surrounds us, and it helps us to identify the product that is in every inch and every corner of the world. The logo uses the tetradic color scheme. Every day, more than likely, you drive by a McDonald's or a Wendy's or a Taco Bell. We identify these places based on the colors that we see. These colors, laid out in a color wheel, help us to understand the theories behind the colors that we see. If it wasn't for Newton's color wheel, we might have evolved to understand color in a different way, or maybe the same way. Regardless, Newton gets the credit. And if it wasn't for Bassi, Newton's theories would not have spread as quickly in Italy. She was his greatest champion. She was his biggest defender. Though we don't have direct evidence of Bassi's work on Newtonian physics and the Newtonian theory of light and colors, we do have her references to Newton's theories in available correspondence. Bassi was passionate about physics. What little time she had raising 5 children, she committed every spare minute to being involved with science and physics. She put the University of Bologna back on the map, and she put female physicists in full view. And she proved to us that our role in life can be more than just being the superheroes that we are in the home. We can also be superheroes in the lab. I'm Gabrielle Burchak, and thanks for listening to Math, Science, History. I'm Gabrielle Burchak. This podcast has been brought to you by caffeine. Delicious, wonderful nectar of the gods caffeine. Coffee, tea, coffee candy, you name it. I love it. Thank you for listening to Math, Science, History. If you are interested in reading more about the history of math and science, please come visit me at mathsciencehistory.com. And while you are there, if you like what you're listening to, please feel free to click on that coffee button and buy me a cup of coffee. Until next week, carpe diem.